Hi, my name is Cerrillo, and we're going to look into faults and faults with these three models that I have right here. It's also important to know that this is the map view and this is a cross-section view. So for all the models, this is kind of like the place that we're walking in. That's the layer that we're walking in, which is the youngest layer. And the cross-section is going to be what's happening inside or under the floor that we're walking on. I labeled the layers according to their age. The layers at the bottom were created before, therefore the oldest, and the deposited sediments created new layers on top of the older layers, therefore making the younger layers be on the top. So we have another type of layers, which are igneous intrusions. These happen in between, in the middle of layers. We have your natural layers, and this one just like shoots in the middle of all the pre-existing layers. So the first model we're gonna look like is gonna show us syncline and anticline. The syncline being the synced parts and the anticlines being the high points, which are also the faults. So this fault is a syncline and this fault is an anticline. This happens when the older layers come up to the surface due to pressure. So as you can see at the top, this is a younger layer because it's on top of layer 6. And layer 4 is showing on the surface, as well as layer 5 and 6, which were created before 7. The second model is a fault, and this happens when two blocks slide past each other horizontally, parallel to the strike of the fault plane. So as you can see, you have your layers here. We also have an igneous intrusion, and then these layers, as you can see by the arrows, these layers just pass right by each other. This is a stripelet fault. Third model we're gonna look like, it's a normal fault. So it's important that we know how to label our footwall and our hanging wall. We identify the footwall with an obtuse angle, the top part being smaller than the bottom. The hanging wall will be the opposite and will have a larger top and a smaller bottom. If you want to make it simpler, you want to remember it more easily, a footwall is going to go downhill and hanging wall is going to look kind of like a shelf. It's gonna have like that shelf like shape, so this is gonna be bigger than the footwall. What we have right here is a normal fault. A normal fault happens because the hanging wall is going down and the footwall is staying still. If the hanging wall was going up, this would have been a reverse fault, but this example right here specifically, it's a normal fault. So yeah, these are some faults and faults. I hope that you guys understood and liked this video. Thank you.